So the first question is, at what projectile angle will the range of a projectile equals its maximum height? So first we have to draw a diagram of this problem. Because its range equals to the the maximum height, and we can get something that is equal. So first we have to know the range and the vertical velocity and the horizontal velocity. We can get this angle, and we can get this angle. So to get these two values, we have to know the maximum height and the range. So to get the maximum height, we have to know the time. So Vy equals to Vy0 plus At, because when it falls, when it touches the ground, its velocity is 0, so Vy equals to 0. And Vy0 plus At equals to 0. We can know that acceleration is negative g, so the loss we can evaluate t equals to Vy0 over g. And we know the time, we can get the maximum height, because we know y equals to y0 plus v0t plus half of a times time square. And because we know that after at the beginning the vertical height is 0, so y0 equals to 0, and y vy and the t we evaluate as y vy0 over g, so we can get this to y equals to vy0 square over 2g. And for the range, because we know that the horizontal velocity remains constant, so we can get the velocity as vx0, and when we times the time, it becomes vx0 times vy0 over g. Because the maximum height and range equals, so we can get this to vy0 square over 2g equals to vx0 times y0 over g. So after all, we can get the horizontal velocity and the vertical velocity's ratio is 1 over 2. So we can at last draw this diagram. Vertical velocity and horizontal velocity is 2 to 1. So we can get this angle by using tangent. So the angle finally equals to 63.43 degrees. So the second problem asks, a rescue plane wants to drop supplies to isolate mountain climbers on a rocky ridge 235 meters below. If the plane is traveling horizontally with a speed of 250 kilometers per hour, which is also 69.4 meters per second. So the first question asks, how far in advance of the recipient must the goose be dropped? It asks the horizontal distance. So the first problem is what is dx? So the plane is flying at a vertical height of 235 meters, and it is traveling at speed of 69.4 meters per second. So first we have to get the time when the goose is dropped. So this can be done using this formula. Because we know the y0, the y is 0 because when it lands, its vertical height is 0, and y0 equals to 235 meters is its original position. And because y is equals to 0, and this is, well, 0, and the last one, the g is 9.80 meters per second. And finally, we can get the time as 6.93 seconds. And when we get the time, we have to know that because the horizontal speed remains constant, and we can use the time and the speed to get the distance, which is the range. So the x equals to t times v, and the v is 69.4 meters per second. So at last, the range is, or the x is 480.94 meters. And the second question is, suppose instead that the plane released displays a horizontal distance of 425 meters in advance of the mountain climbers. What vertical velocity up or down should the supplies be given so that they arrive precisely at the climber's position? So it actually asked whether the goods should be thrown upwards or downwards, and it's asked its velocity, vertical speed. And to get the answer, we have to first evaluate the time in this problem. So because we know the distance and the velocity remains constant because it's a horizontal speed. So the time after it lands, it passed 6.12 seconds. So still this formula, because we don't know the Vy0, which is the horizontal speed. In this formula, we can know that y is negative 235 meters. So this position is 0 meters, and this, which is negative 235 meters. So, and we know the time. We'll just get the time as 6.12 seconds, and time square we also know that is, and the g is the g we know, yeah. So the y0 equals to negative 8.41 meters per second, and because this value is negative, and so it's smaller than 0, so we can assume that this goods is dropped downwards, so it's negative 8.41 meters per second down. So the last question is, what speed do the supplies land in the latter case? And to know the speed, we have to know the vertical speed and the horizontal speed, and we add them together to get the total speed. To get the vertical speed, we have to know that when it lands, it goes with this formula. So v equals to v0 plus at. We want to know the v when it lands. The original speed of the goods is 8.41 meters per second. We just turn it to the positive because it's easy to evaluate the answer. And the g, which is also positive because the v0 is positive, and when it times the time, the answer is 68.33 meters per second. And use the parallelogram, not parallelogram, it's Pythagoras theory. We can evaluate the final answer as 97.43 meters per second. In this part, this is the horizontal speed, which the question get. So the third question is, a boat with whose speed in the still water is 1.70 meters per second. Is 10.70 meters per second. the boat has to cross the 260 meters wide river. So we assume this is the river. Arrive area point 100 meter upstream from where it starts. So it actually goes like this, and it lands across the river in here, and the distance between these 2 points is 110 meters. So the boat has to go in for a 45-degree angle. It goes like this because the river has a current, so the river is not still. The river goes like this, and the boat the boat follows this line to arrive this point. So it asked, what is the river's current? We don't know the river's current, so we assume this is VR, V of river, V of river. So first we have to get this length. We can use sine 45 degree because this angle is 45 degree and this is 260 meters, and we get this length as 260 meters times square root 2 meters, and we can get this length as 150 meters because this two lines both equals to 260 meters, and this is 110 meters, so this is 150 meters. So why we have to get these two lines? Because we can draw the diagram like this. So the boat goes like this and the river goes like this. So actually when it adds, the boats actually goes in this way. So we know this, we can get this. No. When we know this, and when we know the actual length of this line, and we can get its speed. So to do so, we know that this equals to 202 square root 2 meters, and this is 150 meters. So we get a ratio, and its speed of this line is 1.77 meters per second. So actually this river's speed is 0.69 meters per second, right? So this is the answer. So the final problem goes like this. So it asks two cars approach a street corner at right angle to each other. So car 1 travels the speed relative to ours is its velocity is 35 kilometers per hour, and car 2 is at 55 kilometers per hour. So first it asks what is the relative velocity of car 1 as seen by car 2. So this is car 1. Imagine you sit in car 2 and it goes straight towards car 1. And you see the car 1 is go towards you because you are going towards car 2 also. So you must see it approaches you. So this is the first vector. And because it goes to west some way, so it goes like this. So when it adds up, its components are going this way. So when we turn into this problem to here, you can see that this angle is pointing to west. So first we have to get the speed. It's easy because it's just we can turn into a math problem. we can get this line, which is x, as 65.119 kilometers per hour. And we also have to get the angle, because it asks the velocity, not just speed, because velocity contains angle and the speed. So here is north. So this is north, so it goes this way, which means it goes 32.47 degree north of west. So the problem here is also the same. So the velocity, so the speed remains the same, but the angle is not. And in the second problem, it asked, what is the velocity of car 2 relative to car 1? So it's the opposite question. So you can also you can also do the same way as the first problem. So its answer is almost same, but it is pointing west of east, 32.47 degree west of east.